And today we'll be discussing the first practical of data structures and algorithms laboratory. In this we'll implement a telephone book directory using a hash table, and we have to make use of certain collision resolution techniques. So for creating our hash table, I'll use a dictionary. Okay, so this is my blank dictionary. Then whenever I create my dictionary, I want all slots of each bucket to be initialized as none, so that whenever the value at a certain position is none, I could insert a new value over there. Okay, so for creating, I'll have a create function over here, and to the create function I'll be passing buckets. Okay, the number of buckets in my table. So for each bucket, so for I in range B, I'll initialize each bucket at that particular index as none. Okay, so so whenever I find out that any address in my hash table is none, I know that I could insert my value over there. Okay, so then I'll have a linearly insert function, linearly probed insert function. To this I'll pass the key to be inserted and the bucket size as parameters. Okay, and for linear probing, I'll first calculate the hash value. Okay, the hash value of the telephone number inserted. So hash, I'll initially keep it as key mod B. Okay, and then I'll see if my table of the hash value I calculated, okay, at that location, if it is none, this means that there is no collision, that particular slot is empty. Okay, so I'll initialize it as my key to be inserted. Okay, or else I'll have to linearly probe and calculate a new hash value, and at that particular position I'll insert my key. So I'll start my loop from for I in range. So for linear probing, our function starts from 0 to b minus 1. Okay, so 0 to b minus 1th bucket. For each bucket I'll search, and our range function goes from this values minus 1, so I'll keep it as b. Okay, so that many times I'll compute the newer hash values if I don't find a empty location. Okay, so my new hash value would be key plus I mod b. This would be my hash value at each iteration. Now I'll again check if my table is empty at that particular newly calculated hash value. I'll insert it. Okay, inserted, and I could just break out of my loop. I don't need to keep searching again and again. Now I think we should also keep track of the number of elements inserted in our hash table. Okay, so if the user wants to insert more than the number of buckets in our table, the user will be prompted as the table is full. Okay, so over here I'll make use of this variable total, and I'll increment it every time I add a value in my hash table. And we'll also keep a check over here. I'll use a flag for checking. So when I'm out of the loop, I'll check if my flag is equal to 0. If my flag is still 0, none of the elements have been the key is not inserted in the table, so that means my table might be full, or the value may not be probed to some other location. So I'll print that particular message over here, table full or key not probed. Okay, so for linear thing, the condition would be table full only. Key not probed would be possible in quadratic probing, where we get secondary clustering. Okay, so my insert function is done for linearly probed table. I'll just copy and make changes for my quadratically probed table. So in this, the initial thing will be same as it is. I'll just make a change over here. This will be I square. And I'll use another variable for my quadratically probed table. I don't want it to be confused with my linearly probed table. Okay, I'll use another table for that matter, table Q, and I'll repeat this thing. I'll initialize each and every bucket of my quadratically probed table as none, and then I could start inserting my values in that. Okay, so basically it's the same function, but the hash function is changing over here. We're adding I square each time to the key and then performing the mod division by number of buckets, and the rest of the things are same. Okay, so we'll first try inserting some elements in our table, and then we'll also implement a search operation, and that's it for this particular experiment. So I'll have to make a menu kind of thing. So while true, I'll ask the user enter 1 if you want a linearly probed table, enter 2 if you want a quadratically probed table, or else enter 0 for quitting. Okay, and choice is equal to okay. Then I'll check if my choice is equal to 1. I'll ask what operation is to be performed. So I'll just I could use another variable over here. Choice 2 is equal to enter 1 for inserting, 2 for searching. We have to implement the searching function after this. Okay, and 0 for going back. And then if my choice 2 is equal to 1, I'll take another input from the user as the key to be inserted in my hash table. Okay, before all of this, I'll have to take the table size from the user as input. So b is equal to integer input, enter the table size, because I have to pass the table size to each and every function of mine. Enter the table size, and then if my choice 3, I'll make this as choice 3 is equal to 1, I am inserting. Okay, so I am I need another variable over here. Key is equal to, I'm taking telephone numbers as input, so they'll be integer obviously. Enter the key to be inserted in the table. Oh, totl q. Enter the key to be inserted in the table. Then before this I could just check if my totq is equal to b. Okay, so I could just print that the table is already full. The table is already full. Okay, so the user could stop entering these things. Else, if the table is not full, then I'll ask the user for the key and I'll insert it in my linearly probed table, and I have to pass the key and buckets, okay, the table size, to my function. And then we'll just repeat this same thing for the quadratically probed table. Okay, if my choice is 2, I am quadratically probing, so it would be qinsert, and this will be totq. Okay, so this has to be totl. I think I've just, okay, I should remove one condition from over here. So I have corrected this thing, and elif, I'll use an elif condition over here. Elif my choice is equal to 0, I'll just break out of my loop and print exited. Now there's another thing I noticed over here. This will only run for one time, and after each iteration I'll have to again specify which table I'm inserting in. So I'll have to perform a looping action over here. Okay, for this thing I'll use a loop. If my character 2 is equal to 0, I am going back in my outer loop. Okay, break. I'll do the same thing over here. So our inserting logic is done. We'll test it first and then we'll build our searching logic. Before testing, we should also implement a printing function. We have to print both the tables. So for printing, I'll define another function, print table. I'll pass number of buckets. Okay, and for I in range bucket, I have to print the values in my table of I, comma, end with, so it will look good. And I'll print table 2, table Q. Before printing, I'll specify what kind of table I'm printing. This is my linearly probed table. And the second one is my quadratically probed table. I'm implementing both the techniques in the same function. Okay, and after that I want to go on the next line, so I'll just print something blank. This is my print table function. So for every iteration in each loop, I'll print table. So I could see what is getting entered in my table after every iteration. And in the end as well, I will print my table. Table size 10, linear probing, inserting 12. So 12 should be inserted at 12 mod 10th location, so second index. Okay, there's an error. Okay, I forgot one line over here. Before initializing the values, we have to first create our hash table, meaning we have to initialize slots from 0 to b minus 1 to none. So I'll have to call my create function for that matter. And then we'll test the entire thing again. 10. I'll go for linear probing. Insert 12. See, 12 is inserted at this location. Okay, I need to even give a new line over here. So /n. I'll run this thing again. Okay, so quadratic probing is working correctly. See, because the first time it will be inserted at I square, so one key plus 1 squared location, so that is the next location, then plus 2 squared location, so plus 4, so it is being inserted at the correct position. So then we'll just try implementing our search functions. So for the search functions are we'll have to just make certain changes in our insert function, and then we'll just have our search function. So for linear search, linearly probed table search, And just one thing, we actually don't need to run this loop for so many times. We could optimize our loop by specifying it as p minus 1 by 2, because otherwise it will just go on searching for more number of times, which is absolutely not required. So for searching, we'll remove this total thing, and instead of adding, okay, if our hash value is none, it means that the key is not present in the table. So key is not present in the table. Okay, or else we'll go on linearly probing and we don't have to initialize anything. We have to just search. Okay, and we won't break out if our we'll have to break out if the hash address is none. Okay, it means the value is not present in our table. We'll print the same message over here again, and we'll also check if this condition is like this. Okay, if our value in the bucket is equivalent of the key, we'll do the same thing. Okay, key is present at location is the hash value. And if flag is 0, then we'll print key not present. And we have to make similar changes in our totq function. So we'll just remove this and key not present. Then we'll just copy this. And our loop goes from b minus I by 2, b minus 1 by 2, sorry, integer of that. And we'll be finding our value in quadratically probed table. The rest of the things are same. Okay, now we'll first insert some values in our table and then we'll search. Linear probing, insert key 12. Okay, location 2, we'll insert 90, location 0. Yes. Now we'll search for 12. Oh, we'll search for 12. Oh, I'm sorry. Second option is for searching. But we'll have to first add that particular condition in our loop. I forgot to add that. Elif. Okay. If our choice is 2, we'll have to go for searching. Enter the key to be searched in the table. And similarly, we'll add this condition for qinsert as well. Before this elif condition, we'll add this one, and we'll go for qinsert. So now it is working for linear probing, and I'll do the same thing for quadratic probing as well. Key to be inserted 23, 33, location 4, location 7, 43. Right, then I'll search for 43. It should be 7, right. And something that's not existing in the table, let's search for that. 90. Key not present. Okay, so our hash table program is working totally fine. So thank you for watching this video.